My dear students, welcome back to our channel. In this video, I will be explaining the Telangana ICET 2024 Shift 1 exam, Section A, questions. Let's get started with a quick revision and some easy tricks to solve these questions fast. Stay tuned. Question 01. X is an integer. Is x divisible by 18? Given statements. X is divisible by 6. 2. X is divisible by 27. Step-by-step explanation. We need to check. Is x divisible by 18? Let's check each statement. Statement I. X is divisible by 6. X is equal to 6k for some integer k. But 18 is not always a factor of 6k. E.g., x is equal to 6 divisible by 6 but not divisible by 18. Not sufficient alone. Statement 2. X is divisible by 27. X is equal to 27k. E.g., x is equal to 27 divisible by 27 but not divisible by 18. 27 not divisible by 18. Not sufficient alone. Combine I and 2. X divisible by 6 and 27. Find LCM of 6 and 27 is equal to 54. So x is divisible by 54. Since 54 is divisible by 18, x also divisible by 18. Both statements together are sufficient. Quick trick. Check if LCM of both statements is divisible by 18. If yes, together sufficient. If not, insufficient. Final answer 3. Both statements together are sufficient, but neither alone is sufficient. Easy tip. Remember, if A and B are both divisors of X, check LCM A, B. If LCM is divisible by required number, then answer is yes. Next question 02. Is triangle ABC with sides A, B, C an isosceles triangle? Given statements. 1. A 2 plus B2 is equal to C2. 2 plus BC, 2 is equal to B plus CA, 2. Step-by-step analysis. Statement 1. A 2 plus B2 is equal to C2. This is the Pythagoras theorem, which tells us triangle ABC is a right-angled triangle. But it doesn't tell us anything about two sides being equal. E.g., A is equal to 3, B is equal to 4, C is equal to 5 satisfies the condition, but not isosceles. Statement I alone is not sufficient. Statement 2. A plus BC, 2 is equal to B plus CA, 2. Let's simplify both sides. Take square roots. Vertical bar A plus B, C vertical bar is equal to vertical bar B plus C, A vertical bar. So, A plus B, C is equal to B plus C, or A plus B, C is equal to B plus C, A. First case. A plus B, C is equal to B plus C, A. Simplify. A, C is equal to C, A, to A is equal to C, A is equal to C. So triangle has two equal sides isosceles. Thus, this alone is sufficient to say triangle is isosceles. Statement 2 alone is sufficient. Quick trick. Statement I just tells right-angled not enough. Statement 2, use algebra, if it leads to A is equal to C triangle is isosceles. Final answer 2. Only statement 2 is sufficient to answer the question. Next question 03. What is the area of the square? Given statements. 1. The perimeter of the square is a multiple of 4. 2. The diagonal of the square is 17 2 cm. Step-by-step analysis. Statement I. Perimeter is equal to 4 times side. If the perimeter is a multiple of 4, say 4k, then side is equal to 4k. 4 is equal to k. But k can be any value, like 1, 2, 3, 10, 100. We can't find exact side or area. Statement I alone is not sufficient. Statement 2. Diagonal is equal to 17 to cm. In a square, diagonal is equal to side times 2. So, side is equal to diagonal 2 is equal to 17 to 2 is equal to 17 cm. Now, area is equal to side 2 is equal to 172 is equal to 289 cm. Statement 2 alone is sufficient. Quick trick. Perimeter multiple of 4. Always true, not helpful. Diagonal given as A2. Use formula. Side is equal to diagonal to area is equal to side 2. Final answer 2. Only statement 2 is sufficient to find the area of the square. Next question 04. Find the greatest of the numbers A, B, C and D. Given statements. 1. A 40 is equal to B 50. A 40 is equal to B 50. 2. C 60 is equal to D 70. C 60 is equal to D 70. Step-by-step analysis. Statement 1. Given. A 40 is equal to B 50. A is equal to B 10. So, A is 10 less than B. We don't know exact values, just that B is greater than A. Can we find who is greatest among A, B, C, D? Statement 1 alone is not sufficient. Statement 2. C 60 is equal to D 70. C is equal to D 10. So, C is 10 less than D. Again, D is greater than C, but no exact values. Statement 2 alone is not sufficient. Combine 1 and 2. We now know A is equal to B 10, so B A. C is equal to D 10, so D C. Still, we don't know actual values of B or D, so we can't compare B versus D. E.g., if B is equal to 100, then A is equal to 90. If D is equal to 80, then C is equal to 70. Greatest is B. But if B is equal to 60, A is equal to 50. D is equal to 100, C is equal to 90. Greatest is D. So answer depends on actual values, which are missing. Even both statements together are not sufficient. Quick trick. Equations like A is equal to B 10 give only relation, not value. To find greatest, we need actual numbers. So, relation is not equal to answer. Final answer 4. Both statements together are not sufficient. Additional data is required. Next question 05. Find the two-digit number x. Given statements. 1. The difference between the number x and the one obtained by reversing its digits is 27. 2. The number is greater than 5. Step-by-step explanation. Let the two-digit number x is equal to 10a plus b, where a is equal to tens digit, b is equal to units digit. So reversed number is equal to 10b plus a. Statement 1. Given. X reversed is equal to 27, 10a plus b, 10b plus a is equal to 279a, 9b is equal to 279a, b is equal to 27a, b is equal to 3. So, a, b is equal to 3 possible. X is equal to 10, a plus b is equal to 10 times 4 plus 1 is equal to 41. Or b, a is equal to 3 possible. X is equal to 10, a plus b is equal to 10 times 1 plus 4 is equal to 14. So possible values of x is equal to 14 or 41. Only two possibilities, but can't choose exact one. Statement I alone, not sufficient. Statement 2. x5. This is true for almost all two-digit numbers. E.g., x is equal to 6, 10, 55, 99, etc. No use alone. Not sufficient. Combine 1 and 2. From I, x is equal to 14 or 41. From 2, x5, so eliminate 14? No, 14, 5. Still both x is equal to 14 and 41 satisfy both conditions. So we still can't find exact value. Quick trick. If condition leads to two values and other condition doesn't eliminate one. Only if one unique value remains. Final answer, 4. Both statements together are not sufficient. Additional data is required. Next question 06. Is the positive integer x divisible by 10? Given statements. 1. X is the sum of 5 consecutive positive integers. 2. X is divisible by 4. Step-by-step analysis. Let's examine each statement carefully. Statement 1. Let the 5 consecutive numbers be n2, n1, n plus 1, n plus 2. Sum. X is equal to n2 plus n1 plus n plus 1 plus n plus 2 is equal to 5n. So x is always a multiple of 5, i.e., x divisible by 5. But not necessarily divisible by 10. For 10, x must be divisible by both 2 and 5. Example. If n is equal to 3, x is equal to 5 times 3 equals 15 divisible by 5 but not by 10. Statement I alone is not sufficient. Statement 2. X is divisible by 4. So x is equal to 4k for some integer k. But this says nothing about divisibility by 5 or 10. Example. X is equal to 8 divisible by 4 but not divisible by 10. Statement 2 alone is not sufficient. Combine 1 and 2. From 1 x is equal to 5 n divisible by 5. From 2 x divisible by 4. Now x is divisible by both 5 and 4. LCM of 5 and 4 is equal to 20. So x is divisible by 20, which means definitely divisible by 10. Both statements together are sufficient. Quick trick. From 1 x is multiple of 5. From 2x is multiple of 4. If x divisible by 5 and 4, then x divisible by 20 divisible by 10. Final answer, 3. Both statements together are sufficient, but neither alone is sufficient. Next question 07. Among 4 friends P, Q, R, S, who is the tallest? Given statements. 1. Q is taller than P. 2. R is shorter than Q but taller than S. So, QRS QRS. Step-by-step analysis. Statement 1 alone only tells QP. Nothing about R or S. So we can't compare all 4 friends. Not sufficient. Statement 2 alone gives QRS. But again, says nothing about P. So can't determine the tallest among all 4. Not sufficient. Combine 1 and 2. From 1 QP. From 2 QRS. Now, comparing all. QP. QR. RS. So clearly, Q is taller than P, R, and S. Q is the tallest. Quick trick. Combine the orderings. If one person is greater than all others, they are the tallest. Final answer 3. Both statements together are sufficient, but neither alone is sufficient. Next question 08. What is the value of x2 plus y2 plus z2 plus t2? Given statements. 1. X plus y plus z plus t is equal to 20. 2. XYZT is equal to 300. Step-by-step analysis. We are asked to find the exact value of x2 plus y2 plus z2 plus t2. Let's analyze each statement. Statement 1. Given x plus y plus z plus t is equal to 20. But with just the sum, we cannot uniquely determine the squares. Example. If x is equal to 5, y is equal to 5, z is equal to 5, t is equal to 5, total is equal to 20. x2 plus y2 plus z2 plus t2 is equal to 4 times 25 equals 100. If x is equal to 2, y is equal to 6, z is equal to 4, t is equal to 8, total is equal to 20. x2 plus y2 plus z2 plus t2 is equal to 4 plus 36 plus 16 plus 64 equals 120. So different sets of numbers give same sum but different squared sums. Not sufficient. Statement 2. Given XYZT is equal to 300. This tells us the product. But again, multiple combinations can give the same product. Example. X is equal to 1, Y is equal to 3, Z is equal to 10, T is equal to 10 product is equal to 300. Squares is equal to 1 plus 9 plus 100 plus 100 equals 210. X is equal to 2, Y is equal to 5, Z is equal to 5, T is equal to 6 product is equal to 2 times 5 times 5 times 6 is equal to 300. Squares is equal to 4 plus 25 plus 25 plus 36 equals 90. So different sets give same product but different squared sums. Not sufficient. Combine 1 and 2. Even when we know x plus y plus z plus t is equal to 20. XYZT is equal to 300. Still multiple combinations possible. X is equal to 2, Y is equal to 6, Z is equal to 4, T is equal to 8, sum is equal to 20, product is equal to 384. Need to find values satisfying both sum and product, but many such combinations are possible. So we still can't determine exact value of x2 plus y2 plus z2 plus t2. Combined statements are not sufficient. Quick trick. If question asks for exact value and the statements only give sum or product, it's not enough. Unless variables are uniquely fixed, we can't find unique square sum. Final answer 4. Both statements together are not sufficient. Additional data is required. Next question 09. Find the two consecutive natural numbers. Given statements. 1. The difference of squares of the two consecutive numbers is 201. 2. The numbers are greater than 50. Step-by-step analysis. Let the two consecutive numbers be n and n plus 1. Then their squares are n plus 1, 2 and n2. So, n plus 1, 2n2 is equal to 2n plus 1. Statement 1. Given difference of squares is equal to 201 to n plus 1 is equal to 201 to n is equal to 200n is equal to 100. So the numbers are n is equal to 100, n plus 1 is equal to 101. Exact values found. Statement I alone is sufficient. Statement 2. Given both numbers 50. That's a range, not an equation. Example: 51, 52 possible. 60, 61 possible. But we can't uniquely determine which pair it is. Statement 2 alone is not sufficient. Combine 1 and 2. We already got the answer from statement I itself, so combining doesn't change it. Quick trick. Use identity. n plus 1, 2, n2 is equal to n plus 1. Set that equal to the given number to find n. Final answer, 1. Statement 1 alone is sufficient to answer the question. Next question 10. Find the number of possible values of the natural number n. Given statements. 1. N vertical bar, 31 n plus 2024. 2. N greater than or equal to 1 n is a natural number. Step-by-step analysis. We are given n, 31 n plus 2024, 31 n plus 2024, mod n is equal to 0. Break the expression. 31 n plus 2024, mod n is equal to 31 n mod n plus 2024 mod n is equal to 0 plus 2024 mod n, 2024 mod n is equal to 0 n to 0 to 4. So n must be a divisor of 2024. From 2n greater than or equal to 1, and since we already assumed n is natural, we only need to count the natural number divisors of 2024. Step by step, prime factorization of 2024. 2024 is equal to 22 times 3 times 132. Use formula for total number of positive divisors. 2 plus 1, 1 plus 1, 2 plus 1 is equal to 3 times 2 times 3 is equal to 18. Final answer. Number of possible values of n is equal to 18. Since 1 and 2 together help us. Statement 1 tells n 2024. Statement 2 confirms n greater than or equal to 1. Final choice 3. Both statements together are sufficient, but neither alone is sufficient. But in this case, statement 1 alone is actually sufficient because it leads to all positive divisors of 2024, and we already assume n is a natural number. So the better answer is correct. Final answer 1. Statement 1 alone is sufficient. Number of possible values of n 18.